So we're going to talk about matter in this video. So we have to say, what is matter, right? Well, in the universe, there's two things. There's either matter or there's energy. So how do you tell the difference? Well, matter has mass and volume. And if something doesn't have mass and volume, it's energy. So what does that really mean? Well, anything you can see, feel, touch is matter. So how do you know the difference between matter and energy, right? Well, all the obvious stuff is matter. So stuff like a TV, a shoe, a person, a dog, all that stuff's matter. But then there's some stuff that's not obvious, like air. I mean, you can feel wind, right? So that has to be matter. It takes up space. Like if I blow up a balloon, obviously the air that I breathe takes up space. And if the wind blows, I can feel it. So all that is evidence that air is matter. So matter is going to be broken down into two categories, substances and mixtures. So substances are broken down into two categories. And here's a typo. Elements and compounds, okay? Elements and compounds. And we're going to take this one step at a time and talk about all this stuff. So how can you tell if something is a substance? Well, I can tell something is a substance because it has a formula. And you know what a formula is? The formula of water is H2O. The formula of carbon dioxide is CO2. You've heard these before. So an element is a substance that's made up of only one kind of atom. Examples of elements are like carbon, hydrogen, oxygen. And so for the example of oxygen, oxygen is only made up of oxygen atoms, or O atoms. So to be able to tell if something is an element, you're going to look at its formula. And if that formula only has one capital letter, then it is an element. If there's more than one capital letter, we'll talk about what that means. But here's an example, H with a little 2 on it. So there's numbers involved in formulas also, but there's just the one capital letter. Other examples of formulas would be capital C would be for carbon, O little 2 would be for oxygen, O little 3 would be for ozone. A compound is made of an atom of more than one element, and they're going to be chemically bonded together. An example of a compound would be water. Carbon dioxide is another one. So we can tell a substance is a compound because when you look at its formula, there's more than one capital letter. So here's an example, H2O. We know H2O is the formula for water. Notice H little 2O, 2 capital letters. Okay? You can have more than 2, but it has to be more than 1 to be a compound. CO2, carbon dioxide, that would also be 2 capital letters. Okay? Anything that's more than 1 capital letter is going to be a compound. Mixtures are more than one substance that are just physically mixed together but could still be separated by physical means. So what that means is you wouldn't have to have a chemical reaction to separate them back out. Like you literally separate them easily by physical means. Okay? So there's two broad categories of mixtures, homogeneous and heterogeneous mixtures. So a homogeneous mixture is a mixture that looks the same throughout. You've heard the prefix homo. It's okay to use your prior knowledge here. You've heard the word homosexual, right? Well, the prefix homo means same. Okay, homosexuals are people that like the same sex. So use that prior knowledge here to remember that a homogeneous mixture is a mixture that looks the same throughout. So examples of homogeneous mixtures. A Kool-Aid. When you make Kool-Aid, it looks the same throughout after you're done mixing. The red curtains in our classroom. If you look at any spot on the curtain, it looks the same throughout. If you make black coffee, but if you don't put anything in it, that would be a homogeneous mixture. Okay. Excuse me, a heterogeneous mixture is a mixture where you can see the different parts. Again, use your prior knowledge here. Hetero, the prefix hetero means different. Okay, so just like a heterosexual person likes people of the different sex, a heterogeneous mixture is a mixture where you can see the different parts. Examples for this one are super easy to come by. Pizza. On a piece of pizza, I can see all the different parts. I can see the crust, I can see the sauce, I can see the cheese, I can see any of the different toppings that you choose. Salad, any kind of salad, but for example, like a green salad, I can see lettuce, cheese, any kind of toppings you put in there. Maybe you have tomato, maybe you have hard-boiled egg, maybe you have onion. Okay, salad dressing. Iced tea. I specify iced tea, so if I have the brown liquid and then ice cubes, okay, you can see the different parts. So another name for a liquid homogeneous mixture is a solution. Okay, so this is another vocabulary word. And there are two types of heterogeneous mixtures we're going to talk about. One is a suspension and one is a colloid. Okay. Suspensions are super easy to recognize because one thing will settle out when you let it sit. So examples of this are going to be things like Italian salad dressing. Okay, when you get Italian salad dressing off the shelf or out of the fridge, you see all the spices on the bottom, you see the water portion on the bottom, the oil portion on the top. You shake it before you use it. Another example would be the ocean. When you walk in the ocean, the sand is stirred up and it's mixed throughout. Okay, colloids are a little trickier. They appear like a homogeneous mixture, but they exhibit the Tyndall effect. So what the heck is a Tyndall effect, you might ask? Well, the Tyndall effect is when light is shown through a substance and you can see the entire beam, like this. Let me show you. Okay. So here you can see there's a laser beam pointed at a glass of water, and see how the laser beam, you can see it because it's hitting the black thing on the other side, but you cannot see the beam through the water. Now watch the actual beam there. So when you spread the laser beam through a colloid, see how the actual particles of a colloid spread the light so you can actually see the laser clear as day in the liquid. So that's how you can tell the difference between a colloid and a solution.